You have a photo of a sneaker. You want the computer to say sneaker, not coat. You will not write a rule for every wrinkle in that shoe. A 28 by 28 picture is 780 for grey numbers. If you try if statements on those numbers, you will drown. Tonight we build a first neural net in TensorFlow with Keras. We go from a blank notebook to a prediction you can read out loud. Picture the path before we type. First comes the data, then one neuron, then a layer of neurons, then sequential to stack those layers, then compile to choose the loss, then fit to train, then predict to read the answer. If you skip that order, you will copy a tutorial and not know which line actually learned. So first, why a neural net at all? A rule list asks you to describe clothing by hand. A net lets the pixels vote, then it adjusts those votes until the label is right. That adjustment is training. The numbers that change are called weights. You do not draw the sneaker by hand. The weights learn the pattern. A single neuron is almost boring, and that is the point. It is a weighted sum plus a bias, then a curve called an activation. Imagine two numbers walking in, call them x1 and x2. The neuron multiplies each by a weight, adds them, adds a bias, then pushes the total through an activation. If the activation is relu, negatives become 0 and positives pass. That hinge lets the net bend instead of staying a straight line. If the activation is sigmoid, the output sits between 0 and 1, handy when the answer is yes or no. One neuron can only draw a straight cut. Picture a table with 4 dots. That is square. 0 and 0 should be off. 1 and 1 should be off. The mixed rows 0, 1 and 1, 0 should be on. A straight line cannot separate those mixed rows from the corners. You need a hidden layer so the net can fold the space. The first layer draws new features. The second layer reads those features and decides. A dense layer is a row of those neurons. Every input talks to every neuron. Dense means fully connected. Sequential means you stack those layers in a list, top to bottom. Keras is the friendly door on TensorFlow. You say sequential, dense, compile, fit. I want you to hear the official sequential sentence, not a slide I invented. On the Keras guide at TensorFlow.org, they say this. A sequential model is appropriate for a plain stack of layers where each layer has one input tensor and one output tensor. Now the dataset. We will not start with handwritten digits, those are everywhere. We will start with clothes, fashionableness, 70,000 grayscale pictures, 28 by 28 in 10 classes. T-shirt, trouser, pullover, dress coat. Sandal, shirt, sneaker, bag and ankle boot. 60,000 for training, 10,000 for a test the model has not seen. That split is how you know you did not just memorize the pictures. Open the Keras classification tutorial on TensorFlow.org if you want the same official clothing net. Now open a notebook, name it first net, one idea per cell. First cell is only the import. Type import TensorFlow as TF, then import numpy as np because we will peek at shapes. Print the TensorFlow version so we know we are on TensorFlow 2 where Keras lives at TF, Keras. Run that cell version noise is normal. Next cell is a tiny XOR so the stack makes sense in your hands. Make 4 rows of 2 bits. That is the XOR table as data. Type x equals an array of those 4 rows. Type float 32. Then y equals the 4 answers off, on, off. A linear dense with no hidden layer cannot learn that table well. The cut is too straight. Sequential input shape 2, dense 8 with relu, dense 1 with sigmoid. 8 hidden neurons is more than SOR needs. That is fine. You are learning the pattern of the code. Compile with Adam and binary crossentropy because each answer is yes or no. Fit for a few hundred epochs on 4 rows. Verbose 0 keeps the notebook quiet. Then preeni, predict of x. You want numbers near 0, 1, 1, 0. If they sit near 1 half, training was too short. Run more epochs. That tiny net is the same pattern as the clothing net. Fewer pixels, same sequential, same compile, same fit. Now the clothes. Next cell loads fashion MNIST from Keras dataset. NIST equals TF Keras, datasets, fashion MNIST. Then unpack train images, train labels, test images, test labels equals fashion MNIST, load data. Print the train images shape. You should see 60,000, 28, 28. Print the train labels shape. 60,000 integers, each a class number from 0 to 9. Look at one label. If it is 9, that picture is an ankle boot. The pixels are integers from 0 to 255. Neural nets train more kindly when those numbers sit between 0 and 1. So next cell divide. Train images equals train images divided by 255.0. Do the same for test images. The point 0 matters. It turns the math into floats. Let us peek at picture 0. A shape print is not a picture. The first training image in this set is often an ankle boot, dark background, a pale silhouette. Each cell is 1 pixel and the label is the class number. Now we build the clothing model. Model equals TF Keras. Sequential, then an opening list. Keras, layers. Input with shape 28, 28. Input tells Keras the picture is a 28 by 28 grid. Next layer flatten. Flatten lines the pixels up into a vector of 784. Dense wants a feature axis, not a height and a width. Flatten is the unrolling, not the learning. Next layer dense of 128 with activation relu. 128 is how many neurons sit in this hidden layer. Each one sees all 784 pixels. Relu is the hinge. It lets this layer draw folds, not only straight cuts. 10 classes. No activation yet. These 10 numbers are logits raw scores, not probabilities. Why leave them raw? The loss we will use knows how to compare logits fairly. That is the official beginner pattern. Close the list. That is the whole sequential. Input flatten, hidden dense, output dense. Call model, summary. Read it like a packing list. Flatten shows output shape none by 784. None means the batch size can change. The hidden dense shows none by 128 and a parameter count. Those parameters are the weights. They start random. The last dense shows none by 10 scores, 1 per class. The total trainable parameters should be around 100,000. Small. It will still learn clothes. Let me walk those layer lines again. Line 1 sequential. The stack order is the architecture. Swap flatten and dense and the shapes break. Line 2 input shape 28, 28. Color photos later would add 3 for red, green and blue. Line 3 flatten. No weights, it only changes the layout. Line 4 dense 128 relu. This is the first place learning lives. Line 5 dense 10. This is the vote for each class. I will show you the same file in Visual Studio Code so you see a script, not only a cell. Name the file first net. Keep the model in one place. Training comes after compile. Dense on TensorFlow. Org is a regular densely connected neural network layer. Units is how many neurons. Compile does not train yet. It chooses the optimizer and the loss. Type model. Compile. First argument optimizer equals Adam. Adam decides how big a step each weight takes when the loss complains. Next, loss equals SparseCategoricalCrossentropy with from logits true. Sparse means your labels are integers like 9 for ankle boot. Categorical cross-entropy punishes a confident wrong vote when one picture has one class. From logits true means we passed raw scores. Do not softmax twice. Metrics equals accuracy. That is the scoreboard. The loss trains. Accuracy reports. Fit is training type model. Fit of train images, train labels, epochs 10. An epoch is one full walk through the training set. 10 epochs means 10 walks. Add validation does split of 0.1, so Keras holds out 10% as a check the weights cannot cheat on. Watch two numbers, loss should fall, accuracy should rise. The first epoch is slowest because TensorFlow traces the graph. Later epochs usually tick faster. When fit returns, random weights are no longer random. They are a map from pixels to classes. Type model. Evaluate of test images, test labels. This set was never used in training. If test accuracy is near training accuracy, you learned a pattern. If it is much worse, you memorized wrinkles. A first sequential like this often lands near 88%. Not perfect. Honest? Now predict. Wrap the model with a softmax layer so the 10 logits become 10 probabilities that add to 1. Call predict on a small batch of test images. Each row is 10 decimals. Look at row 0. Find the largest decimal that indexes the guess class. If the true label is 9 and the guess is 9, it got the boot. print both. Sometimes it will be wrong. A shirt and a coat share a silhouette. That mistake is a teacher. When it is wrong, look at the two highest probabilities. Close means unsure. Huge and wrong means confidently lost. Argmax turns 10 scores into one class index. It does not train, it only points. You now have the whole path. Data sequential, compile, fit, predict. You did not write a wrinkle rule, you trained a map. Load the pictures, scale them to 0, 1. Stack input, flatten relu dense, then 10 logits. Compile with Adam, sparse categorical cross-entropy from logits and accuracy. Fit for epochs. Evaluate on held out pictures. Softmax only when you want to read probabilities. If summary shows the wrong output width, you chose the wrong number of classes. 10 classes need 10 logits. If loss is not a number, you mixed integer labels with a loss that wanted one hot, or you softmax twice. If accuracy sits at 10%, you are guessing at random among 10 classes. Check the divide, then the labels. The sneaker was never a rule list. It was 780, 4 numbers, 10 scores, and 1 argmax.